Hello students, what we are going to learn today is catalysis. It's a very interesting topic and you should know what a catalyst is. You already know this, that a catalyst is a substance that speeds up a chemical reaction. How does it do it? The catalysts do this by providing an alternative pathway for the reaction with lower activation energy. There are two types of catalysis, homogeneous and heterogeneous. In homogeneous, the catalyst is in the same phase as of the reaction mixture. In heterogeneous, the catalyst is of the different phase as of the reaction mixture. Okay, so in this case you can see the example is, this is ethyl ethanoate. It's an ester, and when it reacts with water it forms acetic acid and ethanol. Now you can see this is catalyzed by hydrogen ions and they are in the same phase. It is also aqueous and this is also aqueous. Now in this case, the hydrogen peroxide, it is decomposed into water and oxygen in the presence of manganese oxide. Now you can see that the catalyst is in the solid phase whereas the reaction mixture is in the aqueous phase. Okay, now these are the two catalysis that you should know very well. Let's see the examples of homogeneous catalysis. Students, this often involves change in oxidation number of ions involved in catalysis. Okay, so for example, this is hydrogen peroxide, and what happens is the iodide ions are first oxidized to iodate ions. Okay, the iodine, this is the iodide ions, these are the catalyst. So let's see what happens. These are first converted into iodate ions. Okay, and then these iodate ions react with hydrogen peroxide, with the molecule of hydrogen peroxide, and they are reduced back to iodine ions. So the catalyst, it is regenerated. Catalyst is always regenerated in the reaction, and oxygen and water is being formed. So you can see here the overall reaction is the hydrogen peroxide in the presence of iodide ions, it produces water and oxygen. Okay, and this is the example of homogeneous catalysis, as the catalyst and the reaction mixture are all in the same phase. Okay, students, ions of transition elements are often good catalysts because of their ability to change their oxidation number. Okay, so again, this homogeneous catalysis, it often involves change in the oxidation number of ions involved in catalysis. Now students, let's see an example of iodine peroxide disulfate reaction. Students, this is also the example of homogeneous catalysis. In this case, the peroxodisulfate ions oxidize iodide ions to iodine, and this reaction is very slow. Why? Because students, both these ions have a negative charge. In order to collide and react, these ions need considerable energy to overcome the repulsive forces. So we need a catalyst. In this case, the catalyst we use is Fe positive 3. Okay, this ion catalyzes this reaction. It has two steps. In reaction 1, there is the reduction of Fe positive 3 to Fe positive 2. And in this reaction 2, it's the oxidation of Fe positive 2 to again Fe positive 3, and the catalyst is regenerated. So students, in both reactions, the positively charged ions react with negatively charged ions. See, here you can see. And as ions with unlike charges are attracted to each other, so these reactions are more likely to occur than the direct reaction between these two, because they are negatively charged ions. And one more thing, that the oxidation of Fe positive 2 ions to Fe positive 3 ions could happen first. Okay, so in this case, Fe positive 2 and Fe positive 3 both can act as a catalyst. Okay, so in both reactions, the positive charged ions and they react with the negative charged ions, you should know. So that is why this will speed up the reaction, and this reaction is catalyzed by Fe positive 3 or Fe positive 2. This is a slow reaction, and in this case this becomes a fast reaction. So this is also an example of homogeneous catalysis.